This is the first session on percentages. Percentages one, we'll deal with basics. What are percentages? How do we increase percentages? How do we decrease percentages? What is the formula for successive change? When will it work? Where will it work? When should we not use the formula? When should we use the ratio method? So we are going to cover these 6 things in today's session. Percentages one. So you guys tell me, what is or are percentages? Why do we use percentages? What is the idea behind percentages? क्यों यूज करते हैं percentage? If I give you a person A and a person B, their scores, if I say A has scored 240 marks and B has scored 360 marks, who has scored more? Who has scored simply more? More is B. B has scored more than A. Now if I say who is doing better in the exam, who is performing better in the exam, अब out of चाहिए रहेगा. So now let us say the score of A is out of 480 and let us say the score of B is out of, let us say, 900. Who is doing better? Because A is scoring half, A is scoring 50 percentages, B is scoring less than half. So B is scoring less than 50 percentages. So who is performing better? A is performing better than B. So percentages were created to standardize comparison calculations. So out of 100 is called percent. So out of 100, A has managed to score 50. Out of 100, how much has B managed to score? Let's check. 360, 900 into 100. That is how we calculate percentages, by multiplying 100. So B has got 40 percentage score, and A has got 50 percentage. Percent. The French word for 100, per means out of. So out of 100, what is the outcome? That is why we need percentage to perform comparisons, to standardize calculations. More or less, you can look at the number and say B has scored more. But who is doing better in the exam? A. So percent is out of 100. Now, these are the 5 standard calculations that we perform when it comes to percentage. If I give you a number A, let us say the number A is 120, and if I say number B is 140, what kind of percentages can you perform? You can ask me A as a percentage of B. What comes after of B? So A as a percentage of B. So B is denominator. B as a percent of A. What comes after of A? So A is the denominator. Whatever comes after of is the base. Now when I say then, I am comparing B with A. Because I am comparing with A will be the denominator. Here B is what percent more? How much more is B? So B minus A into 100. Standard calculations. 3 standard calculations. If you want to copy this down, observe there are 5 standard calculations we perform when it comes to two numbers. A as a percentage of B, B as a percentage of A, B is what more than A, how much more than A. If you want, you can apply these calculations here. I want to know A is how much percentage of B, into 100. B as a percentage of A, 140 upon 120 into 100. B is how much more than A? B is more than A by 20 units as a percentage. Because I am comparing with A will come in the denominator. I'll further show you the ratio method of calculation in the next slide. This is just an introduction to calculations in percentages. Now I might ask you, B is what? A is what percentage less than B? So I'm looking for less. If I say A is 40, but how much amount is A less? A is less than B by 20. Then B comes below. As a formula, you don't have to bug up this. This is B minus A upon B into 100. Whatever comes after of is called the base. Whatever comes after then is also called the base. Base will be in the denominator. Now, what is the percentage change? Generally speaking, percentage change. For a percentage change to happen, you must have an initial value, you must have a final value. Percentage change is defined as final value minus initial value upon initial value into 100. That is the universal definition of percentage change. Initial value will always come in the denominator because you are changing from initial to final. If I say there are 2 years, let us say one of the years is 2023 and another is 2024. Production of, let us say, some metal is 120 tons and 140 tons. So what is the percentage change from 23 to 24? 20 upon 120 into 100, that turns out to be 1 by 6 into 100. We will see the ratio method in few minutes. But now, is this the change in 2023 or is this the change in 2024? Always the change is assigned to the next year. The change is assigned to the next year or the final year. If the value was declining, let us say this was declining, if this was 120 tons and this was 110 tons, so that will be a negative percentage change. When the final value is more, the positive change. When the final value is less, that is the negative change or percentage decline. Common sense, common observations. Increase will always have a positive change, positive sign. Decrease will always have a negative change or negative sign. In DI, in the last lecture, I have shown you how to calculate percentage change faster. You should not be subtracting numbers for the change. Let me add another slide. Those of you who missed the last lecture, for you guys. See, if I say in 2023, the sale of some commodity was 1238 CR crores, and in 2024, the sale of same commodity was 1346 crores. So how do you find percentage change faster? So bring out your calculators. Always see, if you even write in this format, can I rearrange this in this manner? Final upon initial minus 1 into 100. So always divide final upon initial. Go on, divide and tell me the answer. Use a calculator if you have to. 1346 divided by 1238. In CAT, you will have an on-screen calculator. You will have to use a mouse to answer things. So get into that habit. What is the final outcome? What is the final ratio? 1.87. So now see, here also you are dividing final initial value. Here also you are dividing final initial value. So you subtract 1. When you subtract 1, this will be cancelled and make this 100 times. So you multiply 100 with any decimal. So decimal shifts by 2 points. I had a value 0.87. This decimal will shift by 2 points and land here. So there is a 8.7% growth. Always divide final upon initial. If you are dividing final upon initial, whatever number has come, you remove 1 from this. Remove 1, and this is your percentage increase. If I reverse this, first you guys observe, copy this down if you need to. If I reverse this, if I have, let us say in another example, final value as 1238 and initial value as 1346. Go on, divide both, tell me the answer. 0.9197. So understand, because it is less than 1, when you subtract it will become negative. Don't do that. You simply make it 100 times. Understand, the final value is 91.9%. Final value is 91.9%. So how much below 100 is that? 8.1% below 100. That is the percentage decrease. You can apply this kind of thought process whenever the numbers are difficult to work with in quant as well as in DI. Always divide final by initial. If the ratio is below 1, there's a percentage decline. If the ratio is above 1, there is always a percentage decline. How much incline? Look at the decimal, make it 100 times. How much decline? You first make it 100 times and then subtract. This is how you can increase and decrease percentages pretty fast. A comparison or calculation of percentage increase decrease in a single. You can apply this to quant as well as DI. More. That slide was additional. One is the standard one. That was additional. That was added in this manner. That is removed. You can't go back to it. Start fresh. That's basically a rough page. So now I want you to divide, and this you guys have again done in basic maths, speed maths. Divide 100 by 1, divide 100 by 2, divide 100 by 3, go on, start by 4, by 5. By repetition, you can remember these things very fast. A lot of people have put in a lot of efforts in creating patterns. Arey, 3 बार repeat कर लो. If you repeat something 3 times, you'll have this by heart. You will divide everything or 100 by 1, 2, 3, 4, 5, 6 up to 100 by 50. Maintain pace and speed. Now see, I can try and show you 3 to 4 patterns here, but again, trying to remember, and we'll have to end up again calculating new values. Repeat these numbers, repeat these calculations. Now, by definition, any percentage, if you say 20 percentage, it should be 20 upon 100. 16.66 percentage must be 16.6 upon 100. Upon 100 is percent per 100. You want 18%, it should be 18 upon 100. You want 21%, it should be 21 upon 100. So for a percentage, can I say 100 must be in the denominator? For any percentage, 100 must be below the number. In all 15 cases, if you notice, 100 is above. Cancel this and bring it below. Can I say right hand side has become a percentage now? If I cancel this and if I bring it below, the right hand side has become a percentage. If I cancel this, let us say I'm bringing it below. Right hand side has become 12.5 percentage. So by cancelling this 100, I'm making the numerator 1. What I basically have got for you now is, observe, I'm going to remove the information from the screen. If you need to Take a screenshot or write it down. Do so. Take a photo of this if you want. The idea is when you remove 100, it turns into 1 in the numerator. When you remove 100, it becomes 1 by 1. It becomes 100 percentage. 1 by 2 becomes 50 percentage. 1 by 3 becomes 33.33 percentage. Sometimes it is written as 33.1 by 3. It is the same thing. 1 by 4 becomes 25 percentage. 1 by 5, 20 percentage. 1 by 6, 16.66 percentage. I have this on the next slide, don't worry. 1 by 7, 14.28%. The idea is to practice this enough so that you can remember or recall these calculations. This can also be written as 14.2 by 7 percentage. This can be written as 16.2 by 3 percentage. 0.66 is 2 by 3. 0.28 is 2 by 7. So you can remember in pure decimal form or mixed fraction form. These are called mixed fractions. We'll see more examples. Randomly speaking, if I say I have 1 upon 15, that is basically 6.66 percentage. If I have 1 upon 13, 1 upon 13 is 7.69 to be precise, but we approximated 7.7%. The idea is you should practice enough so that you can recall numbers up to this without a problem. From 1 by 1 till 1 by 15, you must have by heart. Now these you put in some effort and remember. If you want 1 by 16, can I say I can divide this by 2 and achieve at this result? If I want 1 by 18, let us say, can I say I can divide this result by 2 and achieve this one? So after 1 by 15, you don't have to remember everything. Go for the next prime, 17, 19, 23, 29. So you have by default completed all ratios up to 30. You will have to put in some effort, even I will have to put in some effort in these 4-5 numbers on the right side. Up to 15, you go to the nearest pan shop, and every panwadi knows this. When I say panwadi, I mean people who are in the industry, jinka kaam chuna lagana hai. People who have been repeating the same content for 20 years without updating questions. Now, all I want you guys to do in the next 3 to 5 minutes is try to create these percentages, these three, based upon these 15 numbers on the right side. Try and create 37.5 percentage, 27.27 percentage, 21.42 percentage based upon what is on the right side. And I have kept these very simple, very straightforward. 37.5%. If you look at the table on the right side, can I say this is the only ratio with a 0.5? Now think of this. Double, triple, 4 times, 5 times, if it clicks. Can I say triple of 12 is 36? Triple of 0.5 is 0.5. So can I say the first one looks like 3 multiplied by 12.5 percentage, which is 3 multiplied by 1 by 8, which is basically 3 by. So whenever, wherever you need 37.5 percentage, try to recall 3 by 8. And again, with practice, you can remember these derived results as well. These are very common, 37.5%, 13.33%, 41.66%, very common. If I talk about B, do you get this feeling that both numbers are multiples of 9? Two multiples of 9 kept side by side. See that happening on the right side. Two multiples of 9 kept side by side. Look at this. Can I say what I have in front of me here is 27.27. Does it appear to you like 3 into 9.09? And what is 9.09 as a fraction? 1 by 11. So basically 3 by. Anytime you have multiples of 9 side by side, you can try and remember 1 by 11. Multiples of 9, 1 by 11. These are the patterns which are printed in books in a unique manner explicitly. But you can remember this in a general manner. Multiples of 9 side by side. Think of 11 in the denominator. If I talk about the third one, see 21.42. These numbers, can I say, look, multiples of each other? Also, they are individually multiples of 7. So look at this. When the denominator itself is 7 here, 1428. When the denominator is 14, do you notice here they are multiples of 7? So if the percentage seems like a multiple of 7, the denominator is also multiple of 7. So does it appear to you like 3 into 7.14? 3 into 7, 21. 3 into 14, 42. Can I say 1.7.114 is 1 by 14? So that looks like 3 by 14. So again, I have kept it simple. Everything is thrice right now on the screen. Apply similar thought process to this one. Fourth, apply similar thought process I applied in the first one. How can you generate 62.5 percentage again 0.5 is there, there's only one number with 0.5, 1 by it. So can you think of a multiple of 12 that comes closer to 6? Multiple of 12 that comes closer to 60? 5 times. So 5 times of 12, 60. 5 times of 0.5, 2.5. Another way to look at this is, can I say, 37.5 plus 62.5 adds up to 100? Yes, no? So 100 percentage is 1. 37.5 percentage is 3 by 8. So what should this be? Can I say that should be 5 by 8? If 3 by 8 is moved on the right side, it will become negative. 1 minus 3 by 8 is 5 by 8. So you can think in complements form. The addition of both percentages is equal to 100. So you can subtract 1 or one of the percentages from 1 to get the answer. Try this one. Try E. Again, there are numerous ways to achieve the result E. You could simply do this. Nothing wrong with this. See, 41.66 is 41.2 by 3. This goes up, it becomes 123 plus 2. What is 123 plus 2? 125. This 3 goes below upon 300. Can this is 25 into 5 and this is 25 into 5 by 2. Nothing wrong with it, common sense, because 0.66, what is 0.66? It is 2 upon 3. So you rearrange. This is 41 plus 2 by 3. Because it is a percentage, percentage must have 100 below. So this 3 goes up, 3 gets multiplied, it gets added, 125 upon 100 dropped. You can think of multiple ways. Can I say 50 percentage minus 8.33 is also 41.66? I'm simply trying to show you there are more ways to skin a mongoose, as they will say in Mongolia. Does this calculation match? 50 minus 8, 42. 42 minus 0.33 is 41.66. I am subtracting integers first and then handling decimal part. This is 1 by 2. This is 8.33 is basically 1 by 12. Do you notice the LCM is 12? This is 6 times of 12 minus 1. So again 5 by 12. Now it is highly unlikely that you will remember this answer or outcome in one attempt. Once you come across the same calculation twice, thrice while solving questions, then you can easily recall 41.66% is 5 by 12. Again, theory should be close to or rather below 40% of your preparation. 60% needs to be practice. Solve more questions. You'll come across more similar calculations. How do you plan on creating 13.33? Try, give it a shot. You want to stick with conventional method? Perfectly fine. Look at this. 13, 13 plus 1 by 3 is 13 3 by 3 upon 100. That translates into 40 upon 300. That is perfectly fine. Cancel 0, cancel 0, cancel 2, 2 upon 50. You convert the decimal into its fractional form upon 100, job done. Or else what you could have done is 10 percentage plus 3.33 percentage. 10 percentage is 1 by 10. Now observe, this is 33 percentage. I don't want 33, I want 3.3. Can I say I'm moving decimal to the left? Moving decimal to the left means dividing by 10. So that is basically 1 by 30. This percentage is basically 1 by 30. When I add both, what I will have is 30 below, and the numerator will be 3 plus 1, which is again 4 by 30, which is again 2 by 15. Now, first 6 we were able to create by manipulating these 15 fractions. Observe. By multiplying with 2, multiplying with 3, by adding, by subtracting 2 percentages are randomly created. These you will have to manually calculate. There are no fractions behind this. Can you try and create 18.75 as a fraction? Again, you have access to a calculator. You may not even need a fraction. What you could have done is 18 plus. See, 0.75 is 3 by 4 upon, job done. You have a calculator. You simply multiply 18.75 upon 100 with whatever number you want. You want 18.75 percentage of n, you multiply this, your job is done. Or this goes up, it becomes 72 plus 3, 75, 75 upon 400, and cancel 25 into 3, 25 into 16, job done. You want 30.55%, there is no ratio for this. You can go on and create in this manner. 30 plus, observe, 5 by 9. When same number repeats multiple times, look at this, look at this. I can use 5 by 9 upon percentage. By default is a fraction. Every fraction can be converted into a percentage. Every percentage can be converted into a fraction. You may not remember this, or you may not be able to remember this exact value, but when it is needed, you can convert that into a fraction. Again, we have seen 8 examples, 9 examples on fractions and percentages. First, we derived these results up to this point to mug up these. There's a small pattern if you observe. 23 is 435, 29 is 345. Just observation. Yes. 0.55. See, if it is 0.55, same digit repeating, you can achieve with this. If I multiply 5 and it becomes 55.55. If I don't look at the percentage, it becomes 0.555. Use a calculator. Check this. Use a calculator. Divide 5 by 9 and you will have 0.55. A single digit repeats multiple 9. Use a calculator and check. With a calculator, confirm this theory, confirm this observation. Same digit repeats, divide by 9, job. So with my side, increase, decrease, we will come back, don't worry. Try this, give it a try. What I'm trying to tell you here or show you here is whenever you have a percentage which is a multiple of 10, you start with 100, your job is done. X is 120 percentage more than Y. If I imagine Y to be equal to 100, can I say 10 more is 10% more, 20 more is 20% more because it is on 100. So I can simply say X is 220. Do you agree with this? Anything which is extra on 100 is a percentage increase. If I have, let us say, if Y was equal to 100 and X was equal to 110, that is 10 percentage increase. If Y was equal to 100 and X was equal to 120, that is how much increase? 20 percentage increase. Anything that is extra on 100 is a percentage, that's all. Here the question says, here the question, Y is a percentage of X. Forget this for the time being. X is 120% more than Y. So if Y is 100, X is 220. How much have you added? 120. That is the percentage growth. On 100, whatever you add is a percentage growth. As long as it's a multiple of 10, assumption of 100 works beautifully. So X is 220, Y is 100. The question is is Y is how many percentage of X? So Y is equal to 100. This is what the question is trying to ask you. Calculate your job is or Y upon X into 100. This is what the question is asking you. So Y is equal to 100, X is equal to 220. This is your answer. Give me answer. Y upon X into 100. Y is a percentage of X. Y is a percentage of X. क्या answer है? Very simple. This 0 is cancelled, this 0 is cancelled, this is cancelled 5 times, this is cancelled 11 times. So 1 by 11 is 9.09. 9.09 into 5. 9.09 into 5. 45.45%. तो आप समझ पा रहे हो? कीप अप हो रहा है आपका? Able to keep up. So basics of percentage. We will go back to increase decrease in a minute. Let us try one more problem. Try this. Very elementary stuff. Percentage 1 is going to be basic. Percentage 2 is going to be slightly advanced. क्यों पेन चला रहे हो आप लोग? Something was supposed to be at a particular number, but because of some mistake, the instructor put a new value there. You want percentage error. First of all, which of these numbers was supposed to be the original value? That is the denominator. What is the amount of error? Bas khatam na. Why do you want to use too much pen? 15 upon 375 into 100. And try not to cancel with 100 till the last step. 15 cancels one time, two time it is 30, and 5 times it is 75. 15 into 5, 75. 1 by 25 into 100, 4 percentage error. Now again, 4 percentage positive error or negative error? Negative error. Very simple childish thing. Last. Give it a try. answers. Again, we are dealing with, I'll say, kind of question which was there in CAT 20 years back. You cannot expect such questions in CAT. Maybe in SNAP you can see such questions. So again, first focus on relevant parts of the question. There's an election involving how many candidates? Two. There are two people who are participating. 68 votes were declared invalid. Because these are invalid votes, they will not be considered for the candidate winning or losing the election. The winning candidate got 56 percentage of the valid votes, votes that matter, and wins by a margin of 96. If the winner wins by a margin of 96, by what margin does the loser lose? 96. If A has got 96 votes more than B, can I say B has got 96 votes less than A? Understand? You will come across a difficult question in the next lecture, which will talk about margin. Winning and losing margin is the same number. The winner wins by what margin? 96 votes. The loser loses by what margin? 96 votes. Because A has got 96 more, winning margin. B has got 96 less, losing margin. Now, the total number of votes polled was how many votes were cast? Can I say people who put a vote in the ballot? The invalid will also be counted. First, I must find out how many valid votes were there, then add 68 to it. Now, the winner has got 56%. Loser will have what percent? 44. Can I say this percentage and this percentage is out of both valid? Both are out of same number valid. So I can add and subtract them. The gap between them is 8 percentage. These 8 percentage votes are equal to 96. So 1 percentage vote should be 12. So 100 percentage vote should be 1200. So this many were valid votes. This many votes decided who will win and who will lose. So how many votes were put into the ballot box? Plus 68. That is your answer. So such kind of questions, you must again observe the key information. I was giving you some extra knowledge here. Winning and losing margin will be same. A wins X margin, B loses X margin. Because they are both a percentage of valid votes. So I can add and subtract. 2 percentage on the same base can be added or subtracted. 1260. Absolute elementary level question. Now for this, we will come back. Let me go to the percentage increase decrease part. So when we are trying to increase the number by percentage or decrease the number by percentage, we would like to achieve that or do that in one step. I'll show you the general approach first. Some number is there n, and you have been asked to increase the number by 20 percentages. So generally, this is what older books say. You should add 20% to the number itself. I can take 20 common, I can take n common, and I can rearrange this number. If the question says another number m must be decreased by 15 percentage, downwards arrow decrease, upward is increase. So because there is a decrease, you will have to perform a subtraction difference. M is common, and you end up with 85 upon. So out of all of this, I want you to focus on two notations here. One is this and one is, Can I say when there is an increase of certain percentage, any percentage, I multiply 1 plus x upon 100, x is the percentage. Another way is how much more do we have here? This is 100. How much more do we have here? On 100, 20 more. We have 20 more on 100. That is 20 percentage increase. If I say a percentage decrease is needed, can I say that looks like 1 minus x upon 100? Whatever percentage you want to decrease, it is 1 minus x upon 100. We will come back to this in topic of SICI. So I'm covering percentage increase decrease here. Now, is the numerator more or less? Less. How much less? 15 less on 100. So this is the multiplying factor approach. You want 20% more, think of this directly. You want 15% less, you think of this directly. Other steps are useless. This notation we will come back to in SICI or profit loss discount. Multiplying factor approach. So 120 upon 100 is the increase factor. 85 upon 100 is the decrease factor. How much decrease? 15%. More on 100 is increase, less on 100 is decrease. Moving on from this, couple of examples. I'll simply write a percentage and then create ratios. Somebody says go on, perform an increase of 27%, perform a decrease of 17%. How do we do this? 127 upon 100 does the job. 83 upon 100 gets the job done. You multiply this, decrease has happened. You multiply this, increase has happened. Some decimals. I'm looking for 15.5 percentage increase. So 115.5 upon 100, job is done. I'm looking for, let us say, 23.33 percentage decrease. Be careful. 100 minus 20, 80. 80 minus 3, 77. 77 minus 0.33. You multiply this, decrease has taken place. Are you able to visualize 100 as a base? Extra on 100 increased. Extra, how much extra? 15.5 extra. Less on 100 decrease. Less on 100 decrease. Now coming to slightly different or a little different approach. It will not be easy for you to increase or decrease this many percentage. I'm going to teach you change of base with 3 or 4 basic examples. You tell me first of all, this is equal to what ratio? 1 by 6. Understand? On 6, 1 is equal to this much. If I'm looking for, let us say, a percentage increase, let me add extra slide for this to cover. This whole process is called change of base. See, 16.66 upon 100 is equal to 1/6. 100 has been replaced by 6 and 16.6 has been replaced by 1. So if I am looking for this kind of calculation, can I say same can be achieved by this? Because 100 has been replaced by 6 and 16.6 has been replaced by. If I'm looking for this kind of calculation, can I say it could be achieved by this? Take a time, observe. This is called change of base. I'm shifting the base from 100 to a known number 6. What I'm trying to teach you here is whenever you come across this percentage, forget increase or decrease, you always find equal to what it is equal to. Now, if the question says 16.66 perform an increase. So do you see on 6? On 6, how much more is there? One more. If a question says perform a decrease, 16.66 percentage decrease. So do you see on 6? Are you adding or subtracting? Subtracting. You are decreasing one further. So that turns out to be 5 upon. So on 6 there is more, 16.66 more. On 6 there is less, 16.6. This is called change of base. We use this when we have decimal calculations out of those 15. 1 by 1, 1 by 2, 1 by 3, up to 1 by 15. We have calculations out of these. We use these fractions. So I'll create a couple of examples for you to understand. On 6, 1 extra, 16.66% extra. On 6, 1 less, 16.66% less. Percentage increase in percentage. बढ़े आगे guys. So this slide we cannot come back to. This is gone. So perform these percentage increase decrease for me. First, I wanted to focus on what is that equal to. 14.28. What is it equal to? 37.5. What is it equal to? Flip pages. You have done this. Flip couple of pages. By I want percentage more. So 1 extra on 6. Percentage less. First you remember equal to. What is it equal to? 1 by 6. You want 1 less on 6. This is basically 1 plus 1 by 6. This is basically 1 minus 1 by 6. Try this one. 8 by 7. And try the last one. I want 3 by 8 increase. Imagine you are going to write this. So 11 by, for decrease, this is what you are trying to achieve. Let us move on. This approach on the right side is called change of base. You have created one multiplying factor 11 by 8 for 37.5 increase. 5 by 8 for 37.5 decrease. This is what I taught you through ratios how to be increasing. Let us say I'm looking for 20% increase. 20% is 1 by 5. I'm looking for more increase 6 by, simple enough. I'm looking for 33.33 percentage decrease. What is it equal to? It is equal to 1 by 3. I'm looking for decrease. What will be the value? Simple. I'm looking for 12.5 percentage decrease. So you first recall equal to 1 by 12.5% 1 by, look at the calculation, look at the ratio you have, 1 by 12.5, 1 by, you want decrease, so 1 less on 8. So see, we have seen 10 examples of increase and decrease with 100, without 100, change of base through ratios. Let me see if you can keep up with this. If I give you, let us say 13 by 12, how much percentage have I increased? How much is more? 1 upon 12 is more. What is 1 upon 12? 8 point. So we are investing so much time here in percentage and ratios that when you come across a difficult question or when you come across a term that involves 13 by 12, you can recall this. If in another example I have, let us say 12 by 13, how much percentage decrease have I got? So a ratio has been given, you can observe increase decrease, or an increase decrease has been given, you can create a ratio. Both are interchangeable. A ratio has been given to you, 13 by 12, that leads to 1 by 12, 8.33 percentage decrease. A ratio is given to you, 12 by 13, that leads to 1 by 13 decrease, which is 7.69, or 7.7 is also fine. So we have seen how does increase decrease work through 100 base, through change of base. Try this. So you need to understand the relation here. The price is increasing by something. We'll come back to this. Expenditure is not allowed. You cannot change expenditure. So what is the ratio between reduction in consumption and regular consumption? Forget the last part of this. What is the relation between price, consumed quantity, and expenditure? Can I say price of the product multiplied by quantity purchased should be equal to expenditure? Yes, no? Now observe what example is being given to you. The price of oil has increased by 30%. Can I say something which was 100 rupees must become 130? 30% increase, yes, no? Now this looks like a ratio between final and what value? This is the ratio for price. What will happen to the quantity ratio? What is happening to expenditure? It is not allowed to increase. Can I say something that does not increase or decrease? It should remain same. This is the ratio approach to increase decrease. Observe. Because there's a 30% increase, 100 has become 130. Quantity, I do not know what is happening to quantity, but expenditure must remain the same. Expenditure must remain the same. one by one. Can I say the quantity ratio becomes 100 by 130, which is 10 by 8. Now come back to the problem, come back to the last part. Pay attention. The ratio between reduction in consumption, it will always be final upon initial, always. Initially you used to consume 13 units. Now finally you are consuming 10. What is the reduction? Reduction is upon regular. What is regular? 13 or 10? 13. So your question is reduction upon regular. 3 by 13. Which option? Now because I am covering this in so much detail, the question itself is worth 30 to 60 seconds. The entire question is worth 30 to 60 seconds. Here I was trying to show you it is always the ratio of final upon initial. Initially it was 100. I am assuming it to be 30. Can I say this looks like 30% increase ratio? That's all. You are increasing the number by 30%. The number itself does not matter. What matters is increase ratio. What should happen to quantity if expenditure remains the? Now people try to mug it up. When there is a percentage increase, there is always a upon 100 plus a percentage decrease. क्या कर रहे हो? What are you doing? Time रखा है कितने एग्जाम में? Don't try to mug up these kind of results. One by याद कर लिया, that's more than enough. चलो, moving on from this, elementary example, very elementary example, 3 by 13. Speed of a Thar is increased by 25%. By what percentage should the time of journey be changed so that Thar needs to travel the same distance? First, slow down. What are the three terms involved? What formula connects them? Speed is equal to distance upon time, or speed into time is equal to distance. Come back to the last line. What do you want the Thar to do to travel the same distance? So distance does not change. Distance is 1 by 1. What have you done to the speed of Thar? Increase by 25%. Can I say 25% increase can be achieved with 5 by 4? What should happen with time to manage this? It is going to be a ratio of time. This is going to be a time ratio. Can I say time ratio is 4 by 5? So initially it was 5. Finally it is 4. Can I say there is one decrease on 5? What is 1 by 5? 20% decrease. A lot of people have mugged it up. When there is 1 by 4 increase, the decrease is 1 by 5. You want to go on that route, totally up to you. Those are called matched pair or offset values. Offset values, offset pairs. 1 by 4 increase will be offset by with 1 by 5 decrease. There is no overall change. So this increase is cancelled by this decrease. That is called offset. This kind of terminology is used in law entrances. Offset value. But again, it's again mugging up. Couple of more problems. Give it a try. Speed of the Thar is increased by 25 percentage. By what percentage should the journey time be changed if Thar needs to travel a distance of 20% more than earlier? Go back to fundamentals. Speed into time is equal to distance. Now plug in values which are given to you for speed, time and distance. 25% is increase. What? Increase in speed. So speed has become 5 by 4. Time I have no idea about. What about distance? Distance is 20% more. 20% more. What is 20% ratio? You can go with 120 by 100 or 5 by or 6 by 6 by 5. So can I say the ratio of the time would be, this is 6 upon 5, this will cross multiply, 24 upon 25. Is the numerator more or less? Less. 1 less on 25. So what percentage will that be? 4 percentage less. We are clear on the ratio method? Now comes the twist. See on the board, does it appear to you, if I think in this manner, speed into time is equal to distance. If there is a percentage change in the speed and there is b percentage change in the time, increase or decrease, we'll talk about later on. Can I say the change in speed and change in time are multiplied to achieve the change in distance? This is called successive change or back-to-back change. The overall change, which is here, the overall change is always the result of multiplication. Observe this part, right side, don't write down, observe. On the right side is always overall change. Overall change is A plus B plus A into B upon 100, always. I want you to write this down. I want you to highlight this part. The overall change is given by A plus B plus AB by 100. I can fit this concept here, but there is no need right now. 25%, 20% are known ratios, so we don't have to worry about that. We use A plus B plus A by 100 when we have percentage like 4% increase, 3% decrease, 15% increase, 8% increase, when they are integer values. When A comma B are integer values, we apply this kind of calculation. I'll give you 5, 6 more examples like this in a few minutes time. The result of multiplication is C. C is always the final outcome. Do not confuse between the placement of A, B and C. Go on, try the 8th problem. Now this in a manner is revision of what you've already done in speed maths. Total number of candidates who appeared the examination at centers A, B, C, D, E. Some numbers are given. Total number of candidates who passed these examinations. Those are also given. The question is, which center can claim highest percentage of candidates passed? Can I say I am looking for pass upon appeared into 100? This is the percentage I'm looking for. So you don't have to multiply 100. In a comparison, the common part does not matter. Does not matter. For A, I'm not writing their names. For A, 83 people have cleared the exam out of 160. Leave it there. For B, 31 people have cleared out of 61. For C, 27 have cleared the exam out of 53. For D, 41 have cleared the exam out of 82. For E, 37 have cleared the exam out of 70. Are you able to see some kind of pattern here? I have shown you 5 methods of comparison in speed maths. First thing, can I say they are pretty close to half? The numerator is pretty close to half. Now please observe, what is half of this number? 82. So can I say it is already 50%, yes? Plus 1 upon 164, can I say this? What is half of this? Hold on, don't panic. What is half of this? 30.5. I already have 50%. Can I say I have further 0.5 upon 61, which is 1 upon 122? Is this thought process correct? See, I have 30.5 plus 0.5 upon 61. Can I say the first one is 50% and the second one is 0.5 upon 61? I can create a percentage which is equal to 1 upon 122. Is it same? Now you tell me, is 1 upon 164 more or 1 upon 122 more? And you are looking for more. So A is cancelled. Now what is half of this number? 26.5. Again I have 0.5 upon 53, which is 1 upon 106. What is more? 106 or 122? 102 as a number is more, but the ratio will become less. So far the answer looks like, can I say this is exactly half? And this is more than half. C is more than half. This is gone. What is half of this? 36.5 is 50 percentages. Can I say I have 0.5 upon 73, which is 1 upon 140? I have 106 here, I have 146 here. Can I say more denominator? The value falls down. The highest one is, again, is this a question of percentage calculation or ratio comparison? Ratio comparison. Now guys, any Tom, Dick and Harry can start using calculator and divide these values. I am trying to show you how the questions are framed. Everything is very close to half. If it is very close to half, why don't you take off 50% out? Once you take out 50% away from all these numbers, now look at the extra part. Deliberately I had kept one number even, one number odd. 0.5 was the result. 0.5 extra on 61. I could have written this as 0.5 extra on 61, 0.5 extra on 53, 0.5 extra on 73. Can I say 0.5 is same? 0.5 is same in all of them. The denominator is less, the value should be. Be careful. You're right now looking at a CAT question around 2014, 2016. This is what CAT people do. They bring in unnecessary variables to confuse you and trick you. two lumps of iron, nickel, copper together weigh 20 kilograms. So I could have used the word alloy here. I could have said there's an alloy of nickel, copper, and iron. There are two alloys of nickel, copper, iron. Total kilograms are 20. One of them contains 75% iron, 31.25 gram nickel per kilogram. Another lump contains 85% iron, 30 grams nickel per kilogram. The total quantity of nickel in two lumps is 617.5 grams. If two lumps are melted to form one, the percentage of iron will be. Again, you try to look at the key parts of the question. 20 kilogram is created or is formed with two separate parts. In the first one, there is iron content which is 75 percentage. In second one, there is iron percentage which is 85 percentage. And then there are many hints given to us. Look at the screen. Now you are going to mix this and create a single piece of 20 kilograms. Now remember the law of averages. When you combine two things, the overall average will always be between the extremes. Between 75 and between 85, do you see any number on the screen?